In question 8, the diagram shows the curve with equation y equals to 2x minus 3 to the power 4 and y equals to 2x minus 3 whole squared plus 1 meeting at points A and B. In part A, it says by using the substitution y equals to 2x minus 3, we have to find by calculation the coordinates of A and B. So now using the substitution, the first equation will now be written as y is equals to 2 into 2x minus 3. So we'll substitute u in place of 2x minus 3 to the power 4. And the second equation will become u squared plus 1. Now we'll solve them simultaneously. So we'll equate the equation. This will become 2u to the power 4 is equals to u squared plus 1. Taking u squared and 1 on the left hand side, this will be 2u to the power 4 minus u squared minus 1 equals to 0. Now solving this equation quadratically, we can use middle term breaking over here. So this can be written as 2u to the power 4 minus 2u squared plus u squared minus 1 equals to 0. Taking 2u squared common, this will become u squared minus 1. Taking 1 common, this will become u squared minus 1 equals to 0. So this will be 2u squared plus 1 into u squared minus 1 equals to 0. So u squared will be is equals to positive 1 and u squared will be is equals to minus 1 upon 2. As we can find the square root of a negative number, so the value, so u squared will be 1 and square root of 1 will be, so taking the square root on both the sides, the value of u will be plus minus 1. Once we have the value of u, we can find the value of x. So as u is equals to, now as u is equals to 2x minus 3, first taking u is equals to 1, this will become 2x. So the 3 will go on the left hand side. This will be 4 is equals to 2x. So x will be is equals to 2. And the second value of x will be when we take u equals to minus 1. So taking u equals to minus 1, that will become minus 1 plus 3, which is positive 2 is equals to 2x. So the value of x will be equals to 1. Once we have the values of x, we can use either of the two equations to find the value of y. So using y equals to 2 into 2x minus 3 to the power 4. So the equation is y is equals to 2 into 2x minus 3 to the power 4. Taking x is equals to 2, so this will become 2 into 2 times 2, 4. 4 minus 3 is 1 to the power 4. So that will be equals to y is equals to 2. So when x is 2, y is also equals to 2. And when x is equals to 1, so this will become 2 minus 3 to the power 4. And in this case, 2 minus 3 is minus 1 to the power 4, which is also positive 1. So 2 times 1 will become 2. So the coordinates will be when x is 1, y is 2. And when x is 2, y is also 2. So the coordinates of A and B are 2, 2 and 1, 2. In part B, we have to find the exact area of the shaded region. Now to find the area of the shaded region, we'll have to find the area under the graph, area under the equation, graph of the equation y equals to 2x minus 3 whole squared plus 1. So first we'll find the area under this region, then find the area under the region of the equation y equals to 2 into 2x minus 3 to the power 4, and then subtract the two areas. We already know that the coordinates of A and B are 1 and 2, the x coordinates. So this is 1 and this coordinate is 2. So we already have the limits as 1 and 2. So finding the area of the shaded region, first we'll find the area under the graph of the equation. So the equation above is 2x minus 3 whole squared plus 1. So this is 2x minus 3 whole squared plus 1. And we'll subtract it from the equation of the curve, which has the equation 2 into 2x minus 3 to the power 4. In the first step, integrating both the equations, we'll get 2x minus 3. This will become whole cube. We'll divide it by the new power, which is 3, and also divide with the derivative of 2x minus 3, which is positive 2. Integrating 1, that will become an x. Integrating this equation, we'll get 2 into 2x minus 3. The power will increase by 1 and become a 5. We'll divide it with the new power, which is 5, and also multiply it with the derivative of 2x minus 3, which is 2. So this 2 and 2 will cancel out. Now applying the limits in the first equation. So we know that the limits are 2 and 1. So first taking x is equals to 2. So that will become 2 times 2, which is 4. 4 minus 3 is 1. So this will become 1 cube, which is 1 upon 6 plus 2. And we'll subtract it from the lower limit, which is x is equals to 1. So this will become 2 into 1, which is 2 minus 3 minus 1 whole cube is a minus 1 upon 6 plus 1. And now applying the limits to the second equation. So that will become 2 times 2, 4 minus 3, which is 1 to the power 5. So that will become 1 upon 5, and we'll subtract it from the lower limit. So the lower limit is 1. So 2 times 1 is 1. 2 minus 3 will, so 2 times 1 is 2. 2 minus 3 is minus 1 to the power 5. So that will become minus 1 upon 5. Simplifying this, we'll get, so taking the LCM, this will become 2 times 6, 12. 12 plus 1 is 13. So this will become 13 upon 6 minus, and taking the LCM over here, so this will also multiply by 6. So minus 1 plus 6 is a 5. So this will become 5 upon 6. And this will become 1 upon 5 plus 1 upon 5. Simplifying this, we'll get 13 minus 5, which is 8 upon 6 minus, and this will become 2 upon 5. Taking the LCM, so the LCM of 5 and 6 is 30. We can write it as 30. So this will multiply by 5 and this will multiply by 5. So this will become 40 minus, and this will multiply by 6. So this will become 40 minus 12 upon 30. So the final answer will be 28 upon 30, which we can simplify and write it as 14 upon 15. So the area of the shaded region will be is equals to 14 upon 15.